Good day everyone. Today we are going to discuss about problems involving the sum and the product of the roots of quadratic equations. We have to remember that the sum and product of the roots of ax squared plus bx plus c equals 0 are obtained by dividing both sides of the equation by a, resulting to x squared plus b over a of x plus c over a equals 0. If r and s are roots, then the sum should be r plus s equals negative b over a, while the product r times s equals c over a. Let us have example number 1. Find the value of k that makes the sum of the roots of 3x squared plus 18 equals the quantity of 3k plus 3 of x equal to 6. Okay, so let's solve this problem. Solution. We have to make an assumption that if r and s are roots of a quadratic equation, then r plus s is equal to negative b over a. So this is our formula to solve this problem. Okay, the given quadratic equation is 3x squared plus 18 equals quantity 3k plus 3 times x. We have to write this first in standard form. So if you write that in standard form, it becomes 3x squared minus quantity 3k plus 3 times x plus 18 equals 0. So we simply transpose this one to the left side and it becomes negative. So this is now the standard form of the given quadratic equation. Then from this, we can now identify the value of a, b, and c. So the value of a is positive 3, which is taken from the coefficient of quadratic term, meaning the number beside x squared. The value of b is the coefficient of the linear term, or the expression or number beside x. And our c is the constant, meaning the number with no variable beside it. Okay, so you have 18. Then we'll be using the formula r plus s equals negative b over a. Then, if you are going to analyze the given problem, it is stated in the given problem that the sum of the roots is 6. So therefore, instead of writing r plus s, we have to replace this by positive 6. So we have now positive 6, and instead of writing b, we'll replace negative times the quantity of 3k plus 3. So we have this one over the value of a, which is positive 3. Then we'll solve this equation first by eliminating this denominator 3. So we simply multiply this positive 3 to 6. So we have now 18 equals, it becomes 3k plus 3 because we have the negative times negative becomes positive. So we simply copy this one here. Then we can also write that as 3k plus 3 equals 18. So they are exactly the same. Pinagpalit lang natin yung dalawang quantity. Okay? Then we can now transpose positive 3 to the left side, to the right side rather. So it becomes negative 3. 18 minus 3 is equal to 15. Then we have to divide both sides by 3 para maging k na lang yung nasa left side. So it becomes now 3k over or divided by 3 equals 15 divided by 3. 3k divided by 3 is k, then 15 divided by 3 is 5. So therefore, the answer of the given problem is positive 5. So the value of k is equal to positive. Let us have problem number 2. Find k if the product of the roots of 7x squared minus 3x minus k equals 0 is 2. So the product of the roots of this quadratic equation is 2. So to solve that, our solution, and we'll make also a presumption that our r and s are roots of quadratic equation. Then r times s is equal to c over a. Okay? So the given equation is 7x squared minus 3x minus k equals 0. So it is written in standard form. So we can now identify at once the value of a, b, and c. So your a is 7, our b is negative 3, and our c is negative k. So we'll use the formula rs, meaning r times s equals c over a. So rs means the product. It implies the product of the roots. And based on the given problem, the product of the roots is positive 2. So instead of writing rs, we replace that by 2. And c will replace by negative k because that's the value of c. And our a is positive 7. So we have now 2 equals negative k over 7. So to find the value of k, we simply multiply 7 to positive 2. So 2 times 7 is 14. So you have negative k equals 14. So we have to divide both sides by negative 1 because this is not yet the value of k because your k has coefficient of negative 1. So para mas consider nating value ni k na ito, dapat ang coefficient niya exactly 1. Okay, so we divide both sides by negative 1. So you have negative k divided by negative 1 equals 14 divided by negative 1. So we have k equals negative 14. So the answer in the problem is negative 14. Okay? Let us have problem number 3. Find a quadratic equation with roots 2 and negative 3. Okay? So we have to remember that a quadratic equation in the form x squared plus b over a of x plus c over a equals 0 gives the idea that the sum and product of the roots of the given quadratic equation is negative b over a and c over a respectively. So in other words, all we have to do is to get the sum of these two given roots and the product of these two given roots. So we have positive 2 plus negative 3 equals negative 1. And 2 times negative 3 is equal to negative 6. Okay, your negative 1, that is equivalent to negative b over a. Or negative 6, that is c over a. Because this expression, negative b over a, implies the sum of the roots of the given quadratic equation, while c over a implies the product of the roots of the given quadratic equations. From the quadratic equation in the form of x squared plus b over a of x plus c over a equals 0, we can replace b over a and c over a by negative 1 and negative 6 respectively. Okay. But remember that in the sum, we always get the additive inverse. So in other words, if it is negative, then we write it here positive. Then while the product, we have to copy that as is. So negative 6. So we have x plus 1 times x plus negative 6 equals 0. So we have to simplify this one. So if the coefficient is 1, we have to remove that and write this one as x squared plus x minus 6 equals 0. If there is no number beside it, it is understood that the coefficient is 1. So we have there now negative 6 because we have here positive times negative 6, you have negative 6. So the equation that we are looking for is x squared plus x minus 6 equals 0. So this is our answer for problem number 3. Okay, I hope you learned something from our lesson. Thank you for watching. Bye.